Hi, this is Sleeper. Welcome back to my channel. We are continuing the read through of the Web Security Academy with Access Control. Access Control Vulnerabilities and Privilege Escalation. In this section, we describe privilege escalation, the types of vulnerabilities that can arise with access control, and how to prevent access control vulnerabilities. What is access control? Access control is the application of constraints on who or what is authorized to perform actions or access resources. In the context of web applications, access control is dependent on authentication and session management. Authentication confirms that the user is who they say they are. Session management identifies which subsequent HTTP requests are being made by that same user. Access control determines whether the user is allowed to carry out the action that they are attempting to perform. Broken access controls are common and often present a critical security vulnerability. Design and management of access controls is a complex and dynamic problem that applies business, organizational, and legal constraints to a technical implementation. Access control design decisions have to be made by humans, so the potential for errors is high. Vertical access controls. Vertical access controls are mechanisms that restrict access to sensitive functionality to specific types of users. With vertical access controls, different types of users have access to different application functions. For example, an administrator might be able to modify or delete any user's account, while an ordinary user has no access to these actions. Vertical access controls can be more fine-grained implementations of security models designed to enforce business policies such as separation of duties and least privilege. Horizontal access controls. Horizontal access controls are mechanisms that restrict access to resources to specific users. With horizontal access controls, different users have access to a subset of resources of the same type. For example, a banking application will allow a user to view transactions and make payments from their own accounts, but not the accounts of any other user. Context-dependent access controls. Context-dependent access controls restrict access to functionality and resources based upon the state of the application or the user's interaction with it. Context-dependent access controls prevent a user performing actions in the wrong order. For example, a retail website might prevent users from modifying the contents of their shopping cart after they have made payment. Examples of broken access controls. Broken access control vulnerabilities exist when a user can access resources or perform actions that they are not supposed to be able to. Vertical privilege escalation. If a user can gain access to functionality that they are not permitted to access, then this is vertical privilege escalation. For example, if a non-administrative user can gain access to an admin page where they can delete user accounts, then this is vertical privilege escalation. Unprotected functionality. At its most basic, vertical privilege escalation arises where an application does not enforce any protection for sensitive functionality. For example, administrative functions might be linked from an administrator's welcome page, but not from a user's welcome page. However, a user might be able to access the administrative functions by browsing to the relevant admin URL. For example, a website might host sensitive functionality at the following URL: insecure-website.com/admin. This might be accessible by any user, not only administrative users who have a link to the functionality in their user interface. In some cases, the administrative URL might be disclosed in other locations, such as the robots.txt file, insecure-website.com/robots.txt. Even if the URL isn't disclosed anywhere, an attacker may be able to use a word list to brute force the location of the sensitive functionality. In some cases, sensitive functionality is concealed by giving it a less predictable URL. This is an example of so-called security by obscurity. However, hiding sensitive functionality does not provide effective access control because users might discover the obfuscated URL in a number of ways. Imagine an application that hosts administrative functions at the following URL: insecure-website.com/administrator-panel-YB556. This might not be directly guessable by an attacker. However, the application might still leak the URL to users. The URL might be disclosed in JavaScript that constructs the user interface based on the user's role. This script adds a link to the user's user interface if they are an admin user. However, the script containing the URL is visible to all users, regardless of their role. Parameter-based access control methods. Some applications determine the user's access rights or role at login, and then store this information in a user-controllable location. This could be a hidden field, a cookie, a preset query string parameter. The application makes access control decisions based on the submitted value. For example, as follows. So admin equals true or role equals 1. This approach is insecure because a user can modify the value and access functionality they're not authorized to, such as administrative functions. Broken access control resulting from platform misconfiguration. Some applications enforce access controls at the platform layer. They do this by restricting access to specific URLs and HTTP methods based on the user's role. For example, an application might configure a rule as follows: deny post /admin/delete user managers. This rule denies access to the post method on the URL /admin/delete user for users in the managers group. Various things could go wrong in this situation, leading to access control bypasses. Some application frameworks support various non-standard HTTP headers that can be used to override the URL in the original request, such as X original URL and X rewrite URL. If a website uses rigorous front-end controls to restrict access based on the URL, but the application allows the URL to be overridden via a request header, then it might be possible to bypass the access controls using a request like the following: X original URL /admin/delete user. An alternative attack relates to the HTTP method used in the request. The front-end controls described in the previous sections restrict access based on the URL and HTTP method. Some websites tolerate different HTTP request methods when performing an action. If an attacker can use the GET or another method to perform actions on a restricted URL, they can bypass the access control that is implemented at the platform layer. Broken access control resulting from URL matching discrepancies. Websites can vary in how strictly they match the path of an incoming request to a defined endpoint. For example, they may tolerate inconsistent capitalization, so a request to admin delete user may still be mapped to admin delete user, so from all caps to the actual endpoint. If the access control mechanism is less tolerant, it may treat these as two different endpoints and fail to enforce the correct restrictions as a result. Similar discrepancies can arise if developers use the Spring framework. Using the Spring framework, have enabled the use suffix pattern match option. This allows paths with an arbitrary file extension to be mapped to an equivalent endpoint with no file extension. In other words, a request to admin delete user dot anything would still match to the admin / delete user pattern. Prior to Spring 5.3, this option is enabled by default. On other systems, you may encounter discrepancies in whether the / admin delete user and / admin delete user are treated as distinct endpoints. This is most likely all caps. In this case, you may be able to bypass access controls by appending a trailing slash to the path. Okay, the trailing slash. Horizontal privilege escalation. Horizontal privilege escalation occurs if a user is able to gain access to resources belonging to another user, instead of their own resources of that type. For example, if an employee can access the records of other employees as well as their own, then this is horizontal privilege escalation. Horizontal privilege escalation attacks may use similar types of exploit methods to vertical privilege escalation. For example, a user might access their own account page using the following URL. If an attacker modifies the ID parameter value to that of another user, they might gain access to another user's account and the associated data and functions. This is an example of insecure direct object reference (IDOR) vulnerability. This type of vulnerability arises where user-controlled parameter values are used to access resources or functions directly. In some applications, the exploitable parameter does not have a predictable view. For example, instead of an incrementing number, an application might use globally unique identifiers, GUIDs, to identify users. This may prevent an attacker from guessing or predicting another user's identifier. However, the GUIDs belonging to other users might be disclosed elsewhere in the application where users are referenced, such as user messages or reviews. In some cases, an application does detect when the user is not permitted to access the resource and returns a redirect to the login page. However, the response containing the redirect might still include some sensitive data belonging to the targeted user, so the attack is still successful. Horizontal to vertical privilege escalation. Often a horizontal privilege escalation attack can be turned into a vertical privilege escalation attack by compromising a more privileged user. For example, a horizontal escalation might allow an attacker to reset or capture the password belonging to another user. If the attacker targets an administrative user and compromises their account, then they can gain administrative access and so perform vertical privilege escalation. An attacker might be able to gain access to another user's account page using the parameter tampering technique already described for horizontal privilege escalation. If the target user is an application administrator, then the attacker will gain access to administrative account page. This page might disclose administrator's password or provide a means of changing it, or might provide direct access to privileged functionality. Insecure Direct Object References. Insecure Direct Object References, or IDORs, are a subcategory of access control vulnerabilities. IDORs occur if an application uses user-supplied input to access objects directly. An attacker can modify the input to obtain unauthorized access. It was popularized by its appearance in the OWASP 2007 Top 10. It's just one example of many implementation mistakes that can provide a means to bypass access controls. So take a look at that. Insecure Direct Object References, IDOR. In this section, we will explain what Insecure Direct Object References, IDOR, are and describe some common vulnerabilities. So what are IDOR? IDOR are a type of access control vulnerability that arises when an application user supplied input to access objects directly. The term IDOR was popularized by the OWASP Top 10 in 2007. However, it's just one example of many access control vulnerability mistakes that can lead to access controls being circumvented. IDOR vulnerabilities are most commonly associated with horizontal privilege escalation, but they can arise in relation to vertical privilege escalation as well. So we have some examples. There are many examples of access control vulnerabilities where user-controlled parameter values are used to access resources or functions directly. We have the IDOR vulnerability with direct reference to database objects. Consider a website that uses the following URL to access the customer account page by retrieving information from the back-end database. So customer account and customer account number. Here, the customer number is used directly as a record index in queries that are performed on the back-end database. If no other controls are in place, an attacker can simply modify the customer number value, bypassing access controls to view the records of other customers. This is an example of IDOR vulnerability leading to horizontal privilege escalation. An attacker might be able to perform horizontal and vertical privilege escalation by altering the user to one with additional privileges while bypassing access controls. Other possibilities include exploiting password leakage or modifying parameters once the attacker has landed in the user's account page, for example. IDOR vulnerability with direct reference to static files. IDOR vulnerabilities often arise when sensitive resources are located in static files on the server-side file system. For example, a website might save chat message transcripts to disk using an incrementing file name and allow users to retrieve those by visiting a URL like the following. So insecurewebsite.com/static12144.txt. In this situation, an attacker can simply modify the file name to retrieve a transcript created by another user and potentially obtain user credentials or other sensitive information. So we'll jump back. Access control vulnerabilities in multi-step processes. Many websites implement important functions over a series of steps. This is common when a variety of inputs or options need to be captured, and the user needs to review and confirm details before the action is performed. For example, the administrative function to update user details might involve the following steps. 1. Load the form that contains details for a specific user. 2. Submit the changes. And 3. Review the changes and confirm. Sometimes a website will implement rigorous access controls over some of these steps, but ignore others. Imagine a website where access controls are correctly applied to the first and second steps, but not to the third. The website assumes that a user will only reach step 3 if they have already completed the first steps, which are properly controlled. An attacker can gain unauthorized access to the function by skipping the first two steps and directly submitting the request for the third step with the required parameters. Referrer-based access control. Some websites base access controls on the referrer header submitted in the HTTP request. The referrer header can be added to requests by browsers to indicate which page initiated a request. For example, an application robustly enforces access control over the main administrative page at \admin, but for subpages such as \admin delete user only inspects the referrer header. If the referrer header contains the main \admin URL, then the request is allowed. In this case, the referrer header can be fully controlled by an attacker. This means that they can forge direct requests to sensitive subpages by supplying the required referrer header and gain unauthorized access. And location-based access control. Some websites enforce access controls on the user's geographical location. This can apply, for example, to banking applications or media services where state legislation or business restrictions apply. These access controls can often be circumvented by the use of web proxies, VPNs, or manipulation of client-side geolocation mechanisms. How to prevent access control vulnerabilities. Access control vulnerabilities can be prevented by taking a defense-in-depth approach and applying the following principles. Never rely on obfuscation alone for access control. Unless a resource is intended to be publicly accessible, deny access by default. Wherever possible, use a single application-wide mechanism for enforcing access controls. At the code level, make it mandatory for developers to declare the access that is allowed for each resource and deny access by default. And thoroughly audit and test access controls to ensure they work as designed. Once again, my name is Sleeper, and that's a wrap. Until next time.